Hello! Today we're going to look at some statistics, and we're going to look at a thing called the interquartile range, the semi-interquartile range, and a box plot, which is used to represent data. So I've got a little example up here, and we're going to tackle that together. So I'll let you read that example. I'll give you 5 seconds or so. So the semi-interquartile range is probably going to be something new to you, as are these things called quartiles. So I'll explain what quartiles are first of all, and then we'll get on to semi-interquartile range. Quartiles are essentially a way of splitting data up into 4 parts, so into quarters in effect. Now the way we're going to do that is we're going to have to put the data in order first of all. So let me score them off as I do them. So 175 is our first height. Next height in order is 178. Oh yeah, that's one thing I didn't mention earlier. The heights have to be in order, or the data has to be in order before we can work out the quartiles. So 179, 2 179s. And then we've got 2 181s. And we've got a 182 and a 185. So if we want to split this into quarters, the best thing to do is to split it in half first of all. So if I count in from the side, 1, 2, 3, 4, 4 there, 1, 2, 3, 4. So the middle quartile, or Q2 as we're going to call it, often called the median, in fact more often called the median, that is 180. Halfway in between 179 and 181. Now we also have to find a thing called the lower quartile. So we're going to look at the lower half of the data and find halfway in between that. So that's there. We're going to call that Q1, and halfway in between 178 and 179. I'll try and write that a bit clearer, 178.5. Again, doing a similar thing for the upper half of the data. So to find the third quartile, or Q3, that's in the middle of the upper half. So 2 values there, 2 values there, in the middle of those. So Q3 is 181.5. So we found our quartiles. We've split the data into 4 in effect. Now if we were asked for the interquartile range, which relates very closely to semi-interquartile range, that would be Q3 minus Q1. So the upper quartile minus or subtract the lower quartile. So 181.5 subtract 178.5, and that gives us, so that's 3. That's 3. What I maybe should have said earlier is the interquartile range, or the semi-interquartile range, that's a measure of the spread of the data. Measure of the spread of the data. So range is a measure of the spread of the data. That's probably one you've heard of before. So back to this. Interquartile range, Q3 minus Q1. The semi-interquartile range is Q3 minus Q1 divided by 2. So in this case we worked out the interquartile range up here is 3. So it's 3 divided by 2, and lots of you I know like it in decimal form, so 1.5. 1/2. So semi-interquartile range for the heights up here is 1.5. Now one other thing we're asked to do is to draw a box plot to represent this data of heights. And most people tend to find statistics or drawing diagrams, looking at diagrams is a bit of an easier way to interpret statistics. And a box plot is another one of those. So I'm going to draw you a rough box plot here to give you an idea of what it's going to look like. So it's meant to be a straight line. and this is going to be the scale. So my scale, my data goes from 175 as the lowest up to 185. So let me just start at 175, 6, 7, 8, 9, 180, 1, 2, 3, 4, 5, 185, and we could go on, etc., etc. Right, the way we plot a blocks plot, it could also be called a 5-figure summary, or it's used to summarize a 5-figure summary. I'll show you how we do that. So first thing we do is we plot the quartiles. So Q1, 178.5. So 178.5, that's about there. So we're going to draw that there. That's going to be part of our box, as you'll see later on. 178.5. Q2, 180. That's our median. Again, a straight line there. That's going to be part of our box. Q3, 181.5. Part of our box. There. And that forms our box. So that's our quartile box. So Q1, Q2, Q3. We also put in the lower values, the lowest value and the highest value. So a little line there at 175 and another little line at the highest value at 185. And then we join that with a box with a straight line. And that's your box plot to represent this data. It's often referred to as a box and a whisker plot as well. Goodbye, and thanks for watching.